today we are here to learn about Azure Function. So Azure Function is a serverless computing service that is offered by Microsoft Azure. So let's dive in and explore the power of serverless computing and how Azure Function can simplify our development and deployment processes. So feel free to ask questions throughout the session, and let's make this learning experience interactive and enjoyable. So let's start. So we have to follow some knowledge etiquettes like punctuality. So join the session 5 minutes prior to the session start time. We start on time and conclude on time. So make sure to submit a constructive feedback for all sessions, as it is very helpful for the presenter. And keep your mobile devices in silent mode, and feel free to move out of session in case of you need to attend an urgent call. And avoid unwanted chit chat during the session. So let's move to the agenda. So first we will see what is Azure Function, why we use Azure Function. Third, we will see the key features of Azure Function, and then we will look into the event-driven architecture and supported languages and triggers and findings. And after that, we will see the tooling options. And in last, we will compare with the AWS Lambda function. Azure Function. So an Azure Function is known as a serverless technology that is growing faster nowadays. So with the help of Azure Function, we can create a serverless solution that provides us the benefits of write less code, less infrastructure maintenance, and saving in cost. So invest so much efforts in the deployment and maintaining the servers for the application. The cloud infrastructure like Azure, Azure provides us all the latest resources required to keep running our application. So in the case of Azure Function, we just need to worry only about the piece of code that we write to implement, and the requirement of functionality and the rest of the others like infrastructure, environment, and etc. handled by the Azure Function itself. And we have similar technologies like similar to Azure Function like AWS Lambda, Google Cloud Function, OpenWhisk, and we have many more. So let's move to the why we use Azure Function. So Azure Functions are lightweight and serverless. Second, Azure Function are easier to write and deploy. Third, it is very fast to execute because there is no large application startup time, initialization, and other events fired before the code is executed. So that's why it is very fast to execute. And the fourth one, we have Azure Functions. So fourth one, application is triggered when an event is fired. Fifth one, we have auto scale. So Azure Function are compute on demand, and that is scalable. When the demand for the application increases, more resources are allocated automatically to the services. And when requests fall, all extra resources and application instances drop automatically, right? And next we have no need to any infrastructure. So Azure Function do not need any infrastructure, and it have zero maintenance. So next, the Azure Function can be built, tested, and deployed in the Azure portal using a browser. And Azure Function are easy to upgrade. We don't affect it. Don't affect other parts of the websites. So last one, we have Azure Function use industry standards and can communicate with other APIs and databases and libraries. So next we have key features of Azure Function. So first is serverless application. So Azure Function is a serverless compute service that allows you to write code in the language of your choice, and you can pay only for the resources that you consume. Right? So second, choice of languages. So Azure Function supports a variety of programming languages such as C Sharp, Java, Python, JavaScript, Node.js, PowerShell, and many more. So this enables developers to work with the language they are most comfortable with. So third one is the pay per use pricing model. So Azure Function follow a pay as you go pricing model. So you are charged based on the resources used during the application of your function. So this model allows you to scale your application automatically and only pay for the resources that you consume during the application. So which can be more cost effective compared to the traditional server hostings. So next we have bring your own dependencies. So you can bring your own dependencies and libraries to the Azure function. So this allows you to use third-party libraries and packages which can help you leverage existing tools and solutions to build more robust applications. So next we have integrated security. So Azure function provides various security features. You can secure your function using the Azure Active Directory, OAuth, and other identity providers. So you can also integrate with Azure Key Vault to manage sensitive uh, information like connection strings, API keys. So next we have simplified integration. So Azure function can easily integrate with other Azure services such as Azure Storage, Azure Cosmos DB, Azure Service Bus, and more. So this makes it straightforward to build complex workflows and applications by composing functions that interact with various services. Okay, so next we have the Azure function event driven architecture. So when an event arrive to event hub, so basically event hub is a ingest data stream that is designed for high throughput data streaming scenario. So when an event is comes to the event hub, then our function app that is basically use the event hub trigger will be triggered, and so the event is stored into the Cosmos DB, that is a database. Okay, and if the function app fails to store the event successfully, it will then the event will be saved in the storage queue. So so we can process that event later, right? So next we have the monitor. So Azure Monitor collects the performance metrics about the Azure services. Uh, by visualizing these in a dashboard, you can get visibility into the health of the solution. And we have Azure Pipelines. So pipelines is a CI/CD service that builds, tests, and deploy the application. So next we have so next we have supported languages and triggers. So Azure Function supports C Sharp, F Sharp, JavaScript, Java, Python, TypeScript, Shell script, Node, and there are variety of languages that Azure supports. And next, it is supported many triggers and bindings, like some of these are mentioned here. That is mostly used in Azure function, like aspirative trigger, timer trigger, and queue trigger, block trigger, Cosmos DB trigger, and the event of trigger. So here there are the types of trigger and what like type of bindings they can use. So like first one is schedule. So schedule is basically a timer trigger. So Azure Function Service can use it. So it is only have trigger. So similarly, we have a HTTP REST or webhook that used by Azure Function Service, and it have only output binding. So similar, we have all that triggers like blob storage. It have input and output binding both. So next we have so example of trigger and bindings. So here we have a class that is order handler. and we have a function name order value. So when an event comes, it will be triggered, right? So here we use the HTTP trigger. So this trigger, this is the trigger binding for the function, indicating that the function will be triggered by an HTTP request. So the incoming HTTP request will be represented by the HTTP request message, right? So and we have the next queue binding. So basically, this is an output binding to an Azure storage queue, right? And the queue name is specified as AI events one, and the connection string to access the storage account is provided through the parameter AI storage account, AI storage connection. So and next we have async controller that is used for to collect and add messages to the queue, right? So basically, this output binding in the context of the Azure function refers to a feature that allows you to easily write code to external services or resources without writing a lot of code explicitly for those operations, right? So we didn't need to write any complex code to send some events to the Azure storage. We simply add this binding and it's done. So here we will use this event output to add and send the data, send that data event what you want to send, right? So next we have Azure function tooling options. So there are many tooling options that provided by Azure function. So first one we have Azure portal. So Azure portal itself provides a web-based interface for creating, managing, and monitoring Azure function. So you can create new function directly from the portal and access function logs and other details. So second, we have Visual Studio and Visual Studio Code. So it is a Microsoft popular integrated development environment. It is a popular IDE. I think you all worked on Visual Studio and Visual Studio Code. So it is offer extensive support for Azure function development. You can use these IDEs with the Azure function extension to create, debug, and deploy the function seamlessly. Right? And next we have Azure CLI. So the Azure command line interface allows you to interact with Azure resources, including Azure function. You can use the AZ function app command to create and manage and deploy the Azure function from the terminal. And next, we have Azure PowerShell. For PowerShell, uh, Azure PowerShell provides CMD-lets to work with Azure function. You can use these CMD-lets to perform various operations on your function, such as creating, deploying, and managing them. So next, we have Azure Dev. So it provides a comprehensive set of tools for building, testing, and deploying applications, including the Azure function. You can set up CI/CD pipelines to automate the deployment of your functions. Next, we have Azure function core tools. So this is the set of command line tools that help you to develop and test Azure functions locally before deploying them to the Azure. So next we have application insights. So Azure function can be integrated with Azure application insight to monitor and gain insights into their performance and behavior. So next we have Azure monitor. So Azure monitor um, allows you to collect, analyze, and act on telemetry data that is generated by your function, and it is helping you to keep track of their health and performance. Next, we have Swagger. So Azure function provides built-in support for Swagger and OpenAPI that allowing you to define and generate API documentation for your HTTP trigger functions. So last one we have language specific tools. So depending on the programming language you are using, you are using for your functions like C Sharp, Java, Script, Python, etc. So there might be specific language related tooling and SDK available to enhance your development experience. So next we have Azure function versus AWS Lambda function. So now we will compare AWS Lambda with the Azure function. So we will focusing on their unique features and the limitations. Right. So first we have hosting plan. So AWS. So there is one way to run a serverless function in AWS. So deploy it to the AWS Lambda services, right? But Microsoft takes a different approach. They separated the notion of the Azure function program model from the serverless operational models with Azure function. So you can deploy your Azure function to a pay-per-use, fully managed consumption plan, right? And there are other hosting plans also, alternative hosting plans like app service plan. So it provides a predictable pay per hour price. So, but it has limited auto scaling behavior. So next we have premium plan. So it gives you reserved capacity and elastic scaling combined with advanced networking option for a higher price. And next we have a Docker container. You can run anywhere on self-managed infrastructure using the Docker container. And next we have Kubernetes-based event-driven architecture. So brings function to the Kubernetes running in any cloud or on premises. So next we have configurability, right? So when deploying an AWS Lambda function, you need to define the maximum memory allocation, which has to be between 1 to 8 MB and to 3 GB. So it takes a bit of experimentation to define the optimal size depending on the workload profiles. So regardless of the size, all instances run on the Amazon Linux only. On other hand, Azure Functions consumption plan is one size fits all. It comes with a 1.5 GB of memory and one low profile virtual core. So you can choose between Windows and Linux as a host operating system. So Azure Function premium plan comes with multiple instances size up to 14 GB of memory and 4 CPU. Right. So however, you have to pay fixed per hour fee for the reserved capacity. Okay, so next we have programming languages. So AWS Lambda natively supports JavaScript, Java, Python, Go, C Sharp, F Sharp, PowerShell, and Ruby. But the Azure function has runtime for JavaScript, Java, Python, C Sharp, F Sharp, and PowerShell. So Azure lacks the Go and Ruby. Otherwise, the languages option are very similar. Next, we have the programming model. So it's specific vary between runtime, but overall, AWS Lambda has a straightforward programming model. So a function receives a JSON object as input and may return another JSON as output. So the event type defines the schema of those objects which are documented and defined in language SDK. So and Azure function has a more sophisticated model based on the trigger and bindings. So a trigger is an event that is the function listen to, and the function may have any number of input and output bindings to pull and push extra data set at the time of processing. So for an example, an SQL trigger function can also read a document from Azure Cosmos DB and send a queue message. Oh, this is all done declarative by the binding configuration that we see in the previous binding example, right? So next we have extensibility. So serverless functions are more customizable. Here, AWS Lambda defines a concept of layers, a distribution mechanism for libraries, custom runtimes to support other languages and other dependencies. And Azure function enables open binding external so that community can create new types of binding and bring them into function apps. So next we have concurrency and isolation model. So AWS Lambda always reserve a separate instance for a single application. Each application has its exclusive pool of memory and CPU cycles. So therefore, the performance is entirely predictable and stable. But in Azure function, it allocates multiple concurrent execution to the same virtual node. If one application is idly waiting for a response from the network, then other application may use those resources. So next we have the cost. So serverless pricing is based on a pay per usage model. So both services have two cost components, pay per call and pay per GB per second. So the so the price tag for both services is almost exactly the same, like 0.20 per million requested and $16 per million GB per second. And 1 million application running 400 ms each and consuming 1 GB of memory cost less than $2. So there are some differences in the details. Like AWS Lambda charges for full provision memory capacity, while Azure function measures the actual average memory consumption of the application. Right? And if Azure functions application shares the instance, the memory cost is not charged multiple times, but shared between application, which may lead to noticeable reduction. Both services charge for at least 100 ms and 128 MB for each execution. AWS rounds the time up to the nearest 100 ms, while Azure rounds up to 1 ms. So next we have HTTP integration. So AWS Lambda used to require Amazon API gateway to listen to HTTP traffic, which came at a massive additional cost. So recently, Amazon introduced integration with elastic load balancing, which may be more cost efficient for high load scenarios. And the Azure function comes with the HTTP endpoints integration out of the box, and there is no additional cost for this integration. Next we have performance and scalability. So AWS Lambda automatically scales out based on the incoming request. It can handle a high volume of concurrent invocations by provisioning additional resources as needed. You can configure the concurrency limit for a Lambda function to control the maximum number of concurrent executions. And Azure function also automatically scales out to accommodate incoming requests. And you can configure the scale out behavior by setting the minimum and maximum number of instances. So next we have orchestration. So serverless functions are nanoservices. It is a small block of code doing just one thing. And there is the question of how to build large application and system out of those tiny pieces is still open. But some composition pattern already exists. So both AWS and Azure have dedicated services for workflow orchestration, like AWS step functions and Azure logic apps. So both are quite open. The functions are used as steps in those workflows, allowing them to stay independent, but it still solves significant tasks, right? And in addition, Azure provides a Azure durable function. That is a library that brings workflows orchestration abstraction to code, and it comes with several patterns to combine multiple serverless functions into stateful long running flows. So next. So if you have any questions, you can ask related to Azure.
Akshita, you have a doubt? Hello.
Hello.
Hello, I'm audible.
Yes, yes.
So there is a languages that is supported by Azure function, and if a person knows any other languages, then what is the alternatives for them?
So there are many SDKs that they provides by the Azure function related to language specific. So you can use use those SDK and you can write your code your own language.
Okay, thank you. Hello. Another doubt is, can you explain auto scaling of Azure function, how it's happened and when it's happened?
So when it scale automatically when the loads come to Azure function, it will scale up automatic, and when the loads goes down, it will scale down.
So it depends on a number of uh,
Uh,
execution of the function.
yes, 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 right.
Okay.
So in this session, we give a basic introduction of Azure function. So we have next session on 18th of August, and uh, we will start that session with we will go through with the Azure. We will create a function app in C#, and we will show you all how it works, like how we can deploy Azure function. So in next session, we will show you more. You can learn more about the Azure function. So if you have any question, you can ask right now.
Okay, guys, I guess, Akshay, thank you for this session. But yes, of course, in case if you have any questions, please do ask, because it will help you out to solve the queries.
Yeah, yeah, sure.
Any questions, guys?
You are facing any challenge related to Azure function app, you can ping me.
Any questions? Abhishek, Shubham, Nancy, Diksha, Kartike, Balraj, Priya.
Yes, sir, I have to ask my question.
Okay. Okay, Akshit. So I suggest I suggest that you ask the questions, related to this session that you just conducted. So it will give you more clarity upon how engaging and how, informative your session was. So I think you can ask questions and these guys will answer.
So yeah, so anyone can tell me one difference between Azure function and AWS Lambda. Any feature that
So there is a cost difference. AWS Lambda is a basically on pay-per-use model, and Azure functions depends on number of requests, like $0.2 per request, I guess. Per
yeah.
request, not per request. It's a some amount of request that's I have not remembered, but yes, it's like that.
Yeah, actually it is less than $2.
Yes, yes, exactly.
Right. Mhm. Okay, so next question is any two key features.
First is serverless service. It's a serverless service. We don't have to manage the backend instances. And another is it's a lightweight. We can write a small piece of code and we can execute it according to different events and triggers.
Mhm.